Welcome to Adding and Subtracting Fractions with Like Denominators. I'm Joe Ratasky.
And I am Emily DeVizio.
Glad to have you with us whenever you're watching this. We'd first like you to pause and examine this task. So as soon as I'm done, I'm telling you what to do, pause this, and you can work on this by yourself, or if you're watching this with a team or a partner. So look at the student work that we have below and think about what misconception or maybe a misapplication of prior understanding that this student is showing. And how could maybe manipulatives or models help the student understand this concept? So go ahead and pause and we will see you in a couple minutes. We're going to look at quickly just decomposition of fractions. So this is something that students would have begun doing in third grade. And in fourth grade, they're simply adding in that addition notation. This isn't that different than what students have been doing at primary grades of decomposing whole numbers to add and subtract.
As Joe said, we want the students thinking flexibly about the fractions as well, so we do want to spend some time decomposing mixed numbers as well. Here you can see this example of students having some practice with decomposing mixed numbers would support that student perhaps in that first task with the misconception that they were having.
And this decomposition of fractions is going to occur in GCG 1 of this unit. Just as Emily said, if we're reflecting on that task that you looked at, you can see perhaps this student was making a misconception that when I subtracted with whole numbers, how I would always bring over 10, break up a 10 into 10 ones, or break up 100 into 10 tens. Well, perhaps that's what they did here with crossing off the 4, making it a 1, and taking that whole and making it 13 eighths. Instead of, if we had them drawing models using manipulatives to know that, oh, this time my whole, because I'm using eighths, when I break it up, it's going to be broken up into 8 eighths. So I'm only going to be using 11 eighths and taking 7 of those eighths away. So hopefully you can make that connection back to that decomposition and how important the models are going to be.
Definitely will help them to see things more visually.
As connecting students' prior understanding with whole numbers to fractions such as decomposition, we want to also connect their understanding of what it means to add and subtract. So before in primary, kids were adding, subtracting items, measures such as counting bears, things like that. It was easy for them to say 5 bears plus 5 bears is going to be 10 bears. It's a little bit confusing now as they're using fractions because that item, that thing that they're quantifying, is defined by a number in the denominator. So when we're looking at fourths, we see a 4 in the denominator, but we really want them thinking, oh, I'm adding or subtracting these things called fourths or thirds or fifths, whatever it might be. So when we're talking about having 6, I have 3 6. Those 6 are the thing I'm counting, and 2 6, I'm adding 2 more of them. That's going to give me 5 6.
I definitely thinking about fractions and what you just said. I think that teaching fractions in context would support students with their understanding of that. So make sure that you're using fractions in context so that the students are able to visualize and understand what is being asked of them in the problem.
If you look at that third bullet, trying to not let the fraction get in the way of the problem. So you could use simpler fractions, making sure that they're not having to regroup and make a new whole at first if they're adding or subtracting. This would also be a good time to use numberless word problems, or even substituting in, here's some whole numbers in this word problem, then pull those whole numbers out and put in fractions. So once they understand the context, now we're just changing the quantities that they're working with.
So here are some situations involving addition and subtraction, and just like we do with whole numbers, we want to expose our students to the different problem types where we have some that are result unknown, change unknown, and students are able to use different strategies to solve those problems.
And the type of problem that you choose here could lead to different strategies, such as using a take from change unknown. That could help students to see more of a counting up strategy rather than a taking away strategy.